All right, in this video, I'm going to show some of the components of a power supply unit. I'll also be showing you how to test a power supply using a digital multimeter and power supply testing equipment. Let's start with some common symptoms, though, that may indicate a failing or failed power supply. They're pretty clear-cut. If a PC doesn't turn on at all or randomly shuts down, or maybe the power supply unit or PSU fan isn't spinning or otherwise makes noise, that's all logical reason to question if the PSU is functioning properly. Additionally, a PSU may be malfunctioning or underpowered if shutdowns occur while placing a large load on the system, such as when playing a game with heavy graphics or trying to run programs. So before diving into the inside of a computer, though, we want to make sure that we've checked for common causes. The computer should definitely be plugged in, right? Is there power at the wall? Is the power switch on the power supply unit in the proper position? And furthermore, is the voltage selector in the proper position? We're going to take a look at those things as part of components of our power supply unit here in just a second, but you always want to check the easy things first before diving into the inside of a computer. Don't ever try to make a problem harder than it actually is. We always got to check the easy stuff first. And so ensuring that it is definitely plugged in. And that's where, the saying comes from, have you tried turning it off and on again? Like, if we can solve a problem an easy way, not to be lazy, but we just need to make sure that we're not using more of our time, resources, or risking exposure to other components for no reason. So always check those easy things first when you're working with power supply or resolving IT-related issues. So once we've checked for the easy stuff and proper symptoms still persist, we can justify disconnecting and testing the power supply unit. So I'm going to show you 3 different tools that we'll use in the lab and in the field that you can also use to test a computer power supply. But before I do, let's go over some of the components of the 2 power supplies that I have with me today. So I've got this EVGA. It's a 460 watt bronze power supply, and you're going to notice we've got our connector for power. We've got the power switch. This is binary, so 1 would be a value of true or on, and 0 is a value of false or off. It's empty. Okay, so that's how we know if they're turned on or off. This one does not have a selector switch variable. It's looks like it's automatic selecting between 100 and 240 volts. Okay, and we've got a few different connectors. Let's go ahead and try and go over real quick. So we've got our 24-pin main power connector, and this one is a 20+4. Okay, so we can have the older style 20-pin, but all modern boards are going to be using the 24-pin. We have PCIe or PCI Express, and these can be, you'll see them a lot of times as 6-pin on older configurations. More modern is to have an 8-pin, so that's why they make this as kind of a 6+2, and really you can have up to 2 of these. Okay, so this one has 2. And then our third, these are the 3 main cables on a power supply, is the CPU. Now this one's clearly labeled, okay? In the older ones we'll have 4, and in the modern ones we'll have 8, because as computers became more powerful and more capable, they need more power, right? So some of our less powerful or older models may only have 1 of these, okay? Now after that, that's the 3 main components, and you guys should know all of these by now, but let's pull in a couple of these peripheral cables. Okay, so here's our SATA, okay, and this is SATA for power. Okay, we're not going to test this, by the way, and I'll say this again, we will not test a SATA cable with a multimeter. Those pins are too close together and it's too likely to short something out. But we can test these Molex connectors. Okay, so we've got Molex right here, and Molex is an older style of power cable. And we've got our micro Molex here as well, or some people call that like a diskette drive power. So that's the EVGA brand that I have. Let's look at a couple of differences just real quick between that one and the style you guys will be working with, okay? Now some of these are good and some of these are bad, okay? So you don't know what you're going to get. I do want to point out this one does have the selector switch, and that can go back and forth between 230 volts or, see if I can change it without moving the camera, 115 volts. Okay, so we do have to make sure these are on the proper setting. In the United States, we use the 100, typically are going to use the 115 volt setting, and that's because the power coming out of our walls is between 110 and 124 volts. So we use that 115 volt setting. We still have the power switch, and we still got the power cable. That's pretty much it, Rick. Now let's look at our three main cables, and you're going to notice that it are primary, actually. So they have a P on here. Here's P1, primary 1, and this is our 20 plus 4-pin connector. It's the same pin out as the other drive we looked at, or the other power supply we looked at. We've got our P2, or primary 2. Okay, when you think about it, you got to have main power. That's pretty important. And you got to have CPU power, right? So that's the first two most important ones. So this is our CPU power. And like I said, in these older models, instead of having two, we just have one 4-pin connector. Okay. And then we've got primary 3. What do you think this is? This is our PCI. Okay. Because, yeah, it's important to have video, but that's external video. We may have internal video. So it's important, but it's not as important necessarily as our primary 1 or P1 main cable, our primary 2 or P2 CPU cable. This is our PCIe, primary 3. So also notice the colors on these. In the EVGA, all the cables were black, so it's a little more challenging. But in a more standard power supply unit, these are color-coded. So these have meaning. And the yellow ones are your 12 volt, okay? Black are common or ground. And you can see here we've got some when we go to our peripheral cables, like these micro Molex and Molex connectors. We've got, here's our yellow, so guess how many volts that is? Yeah, that's 12. Black is primary or ground. The red is our, basically our 5 volt, okay? And orange is 3.3 volts, okay? And so let's continue on. You will notice a couple of other differences, and that is that not all of these are going to have built-in SATA, so you might have to use an adapter to be able to convert a Molex to a SATA, and I've got those adapters in the closet. But that's pretty much it, the primary differences between our two power supplies. So let's continue on with safety, okay? You got to remember that power supply units are field replaceable units, or FRPs, so we never open or attempt to repair our power supplies. There's a risk of electrical shock inside of the PSU even after it's been unplugged. We should also ensure that our power cable has its grounding pin intact, right? And so that's on the, if you don't know what that is, ask me and I'll make sure and show you. So that grounding pin, or that third prong of the power supply cable, should also be intact. So I'm going to end up showing you 3 different tools that we'll use in the lab and in the field, like I said before. And the first one is going to be the digital multimeter, and you can see that on the camera here, the second or primary camera, okay? And so when we're talking about a digital multimeter, multimeters are not generally auto-ranging, and they do make some auto-ranging multimeters, which basically means that you can set it to the DC voltage side, and it's automatically going to range the voltage that you need based on what you're testing. Or the AC side, same thing. But a lot of multimeters, especially these cheaper ones, are not auto-ranging. So you have to set the multimeter to a range that it can measure. For example, 2V, if I switch the selector to this 2V, this is going to be able to measure voltage up to 2 volts. If I were to connect this to a much higher voltage, I'm going to blow the internal fuse. This has a fuse inside of it, and I'm going to blow that fuse. So we don't want to do that. The 20V measures voltages up to 20 volts. So if you're measuring a 12-volt battery or a 12-volt DC system, we use the 20-volt setting. Now, if I were going to check current out of the wall, okay, that's 120 volts or up to 120 volts AC or alternating current. So I would use this 200-volt setting to test power out of the wall. Okay, and then I can put those leads right into an outlet and test for that voltage. So like I said, for us, these are 12-volt systems, right? Because that's the highest voltage that we should be having as an output. And we can see that information right here on our label. Okay, so it's we've got our input is 115 volt or 230 volt and 8 to 5 amps, and that's a 60 or 50 hertz cycle. And our output, we have multiple outputs, but the highest one in voltage is 12 volts. You see that? So for that reason, we're going to be selecting an output that correlates to that lower voltage. So we want the 20 volt setting. So notice the colors on the leads, right? So we've got 2 different colors on these test leads. These are called test leads or probes. And these are used to test and measure current in a circuit. They're coded and colored to indicate which one is positive and which one is negative. To test a power supply, like I said before, we'll be using the DCV, which stands for direct current voltage. And in DC, the black wire is called the negative or common wire. And the red wire carries the positive voltage that we're going to be measuring. Okay, so let's look at real quick at where these plug into the multimeter. And you can see on the other camera, we've got a few options, okay? Now, these in blue, we're not going to mess with those. This refers to amperage, okay? And we don't need those for what we're doing. But we do need to connect our negative or our common. Okay, so we're going to connect that one right there. And these are called banana clips, okay? And the other one is going to go into the voltage side, okay? And that's how we know that we have that set up properly. Yours should already be set up properly. You're just ready to go and be able to switch to the proper selection. Let's see, anything else? Well, no, I think we're ready to go. So I've got my power supply unit now plugged into power, and we are on 115 volts. And we're going to turn this on, but in just a minute. Right now, I want to make sure that it's turned off. And in order for us to do this testing with a multimeter, we're going to have to take our main or primary power cable, and we need to jump the pins, okay? There is a setting, and you're going to see this in your handout, but I expect you guys to remember and know it. Basically, there's more colors here than just the red, black, yellow, and orange that we talked about before. We've also got a brown wire, and we've got a blue wire, we've got a green, and a gray. Well, let's talk about this green wire real quick. Okay, so this green wire correlates to the 11, 12, 14th pin. Okay, when we're looking at this, the clip is on this side. This is pin number 1, and this is pin number 12. This is pin 13 and pin 24. And so how that works is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way down, and then 13 to 24 on this side. So this 4th pin down on this side, or 11, 12, 13, 14, that's that green wire, okay? And that green wire is our PS on, our power supply on. And that circuit has to be closed in order to power this up. So you can't really test any of these peripheral cables or even our secondary and tertiary primary cables, okay, for our CPU and PCI, you can't test those unless the power supply thinks that it's powered on. So in order to do that, we're going to use a jumper. And we've created these from a piece of paper clip. All right, so we can take this paper clip, and what essentially we're going to do is use it to connect this green wire to this black wire, and that's going to close that circuit. Okay, so I'm just going to very carefully insert that. We don't want to bend or damage those, but now that's on. And if you'll see, with that in place, if I were to hit this power button, the fan starts to spin. Okay? Whoops, sorry, I moved the camera. If I were to take that out, we'll try and capture it both, that fan's going to stop spinning. And so what this does is this emulates pressing the power button on the computer. Okay? So it's that fourth one. All right, right there. Now, as best practice, you should have the power supply turned off because we don't want to create a spark or short anything out. But I wanted to demonstrate the function that that does for you. Okay, so now we're ready to test. So let's turn our multimeter to the proper setting. Okay, and we're going to try and see if we can get some results here. Now you're going to have a handout that looks something like this, and it's going to have the pinout on it to show the different voltages that you're expecting. And the tolerance is typically pretty small for these, and we can talk about tolerance, but basically for these, let's see, for like pin 1 here, for these 3.3s, the tolerance is only plus or minus 5%. So it's got to be in a range of 3.135 to 3.465 in order to be good. So it doesn't have to be exactly 3.3, but just understand that there are tolerances anytime you're checking electrical circuits, and the tolerance for most of these is a plus or minus 5%. So if it's rated for 3.3 volts, it could be 5% low or 5% high. And there are charts that do the math for us, and that's where I'm getting this information. On our 5 volts, like when we get down to this 4th pin, okay, and that red cable, because remember the red are 5 volts, the tolerance is also 5 plus or minus 5%, and so that means it can be 4.75 to 5.25, even though it's a 5 volt cable. Common, of course, COM is our black or ground. We won't test those. When we get down to a 12 volt, that's our yellow wire, the tolerance is, let's see, looking for it, don't want to tell you wrong. This one's actually a plus or minus 10%, okay? And so these can be as low as 10.8 or as high as 13.2, okay? You know what, correction, that's actually on that 14th pin, the minus 12 volt, and that's that blue wire. On this yellow one, the, let's see, 10th one is actually still a plus or minus 5, so it needs to be 11.4 to 12.6. But there are charts that show us that, and let's go ahead and test a couple, okay? So we're going to hold our clip. This is pin 1. This is pin 12, 13, and 24. And we need to hold the black wire on one of the commons. Now my chart shows me that this one here is a common, and it doesn't matter which one, but see, it does correlate to a black cable. So that's going to be a common, that's a common, that's a common. And I can look at these pinouts, or I can also just look at the colored cables if they happen to be color-coded. So when we're measuring here, and I can hold the other one, I'm not pushing these in, we're just touching. Here's an orange cable. So what should orange be? Orange should be 3.3 volts, right? Between 3.13 and 3.46, and it looks like we're at 3.3. That one's also at 3.3. So we're going to go through and test each of these. This one should be a 5 volt because it's red. Okay, and it is, looks good. That's another common, so we don't need to test this one. Let's see, is this another red? Yeah, 5 volts. Okay, we can jump down to these yellow ones down here. Should be 12 volts. Okay, here's 12 volts. And here's 12 volts. Oh, wait. Hold on. Nope, I looked at it wrong. That's okay, that's an orange cable. So that's 3.3 volts. And we can do the same thing for the other side, okay? And looking at those colors. So if I hold the black on a common, hopefully you can see some of this. Hold the black on a common, then we'll switch it over so we can see. Here's an orange cable, 3.3 volts. Here's our blue one there. We're not actually worried about testing that one. That's a 12 minus. Actually, you know what? Yeah, let's go ahead and test it. So that's minus 12 volts. Notice the little minus indicator that popped up. See here, there is no minus. So that's positive voltage. But here, it's a minus. So that's 12 voltage. Okay, minus 12 volts. Let's see. That's our on. There's some primaries or commons. These are commons. We can tell by the color code. Now, if these were all the same color wire and they weren't color coded like this, like with our other power supply, we would have to use our pinouts and rely on that more heavily. Now, let's look real quick at this CPU connector, okay? So our CPU pinout, we can see right here, shows that pins 1, here's the clip. The ones on that side are common and the ones on the side are 12 volt. And we can also see that in this case because they're color coded. So here's our common on this side and our positive voltage there. So when we're testing these, we're going to take our common, that's going to be the ground, okay, or the black cable goes on that side, okay, and we're going to check our positive. There we go. We're at 12 volts and 12 volts. Okay, now if you wanted to check this other ground, then we can do that too. Now, what if I got these reversed? What if I put my black on the positive and my positive on the negative? What would happen? Any theories? Any ideas? What do you think would happen? It's going to show it a negative value. So I'm going to get a false negative reading because I have my pins backwards. It's still going to read it, but it reads it backwards, so it thinks the values are negative. These aren't negative voltage. These are positive voltage, and when I do it the right way, that's what I see. All right, same thing. We've got our PCIe connector, okay, and we can see from our pinout, you know, how it works, but we can also just tell in this case, since they're color-coded, how many volts are yellow? That's right, they're 12 volts. And how many volts are black? Oh, there's none. That's the common wire. That's like a ground, just to help complete the circuit, okay? So we can test each of these. All right, got it in there. There's 12 volts. There's 12 point, so it's 12.17. Is that within the tolerance? It should be. These are plus or minus 5 volts on the positive 12 volt. And so as long as it's 11.4 to 12.6, we're good. And there we go. We're good. Now, to test a couple more, let's do a Molex real quick. We can do the micro Molex. Instead of trying to stick something in here, it's too small, we would just hit the back of it, and there we can see common. We can see our 12 volt. There's a 5 volt. So I just hold this tip onto a common. It's a little more challenging. And here, these big ends. All right, there we go. See if I can get a reading out of it. There we go. Minus 5 volts. You know why? Because I got my connectors backwards. But it is 5 volts, right? So if we want to test it proper, here, let's test this 12 volt one. Okay. And it's a little bit harder to get the connector down in there, to be honest with you. But we can do it. There's 12 volt. All right. And we can check our Molex connectors, okay? Molex connectors color-coded the same way, or we've got our pinout that shows that pin 1 right here is 12 volt, common, and 5 volt, okay? But we can test those by putting our leads in and just touching ever so slightly, and right there. So guys, this one, I'm going to go ahead and say is a good power supply, okay? Now, if I want to be sure, and you're going to do this, we've got 2 different types. We're done with this, okay? So we've got 2 different types of power supply testers that we're going to look at, and this is the one just like in the video, okay? Now, this one has a momentary on-off switch, so you actually have to press and hold it, but when we connect, let's remove our little jumper and connect this into our 24-pin side, okay? And if I press and hold this, oh no, it's saying I don't have a plus 12 volt. What that's referring to is my CPU. So we're going to have to at least have the CPU connector also, okay? Now if you look real close right here, I don't know if you'll be able to see it on the camera, but here it tells you CPU 8, CPU 4, PCIe 8, and PCIe 6. Well, we've got a 4-pin here. So let's connect that 4-pin. Okay, I don't think is that the way it plugs in? Nope, it goes in like this. Okay, now when I hold the momentary switch, it's going to show me an actual value. Okay, can't really make that camera do anything useful anymore, but it's going to hold a positive value. And that's only as long as I hold on it. Now, I've got other connectors like here. We can go ahead and test our SATA. Okay, so we're going to disconnect that. We can put our SATA on here. All right. And now we're picking up SATA voltage. Okay. I thought that would actually show through. I don't like this style connector as well because it's kind of tough to read. Let me show you my favorite one real quick, and then we're going to end this video, and you'll be ready to come test some power supplies. This one here has all the connectors on one end. And if you look on the back, this is PCIe, that's the red ones, and CPU is the black one. And then we've got Molex and SATA. There's SATA, that little green chip right there, and there's our Molex. Okay, this one does not test the micro Molex, but this is the one that we use in our shop and in the field. So as soon as I connect something, you'll see it updates it and shows that we've got that 24-pin connected that we've just connected, okay? And let's see, we can go ahead and get our CPU connected. And we've got a 4-pin CPU. Now it knows that the CPU is connected. And let's go ahead and get our other primary, okay, our PCIe. And now it knows PCI is connected. And just for fun, let's go ahead and connect Molex and a SATA. Now, you would need to test. To really know, you need to test each one of the connectors on this peripheral. So it's not just this one, but it's also every other one that's connected to it. And once I've done that, that peripheral line is checked, then I would need to go check this one. Here's a Molex, here's a SATA. Okay, there's no more. Now that peripheral line would have been checked. And we're going to continue on until we've checked each of the peripheral lines. All right, let's go ahead and real quick. Got just a few more minutes. Let's connect a SATA in here if we can. I don't know if it'll fit because everything's so tight. Okay, so now you can see on the video we've got a 24-pin connector and everything is right. It's reading good. If we had a problem, what I like about this one is it also automatically indicates for you if it's if the voltage is out of tolerance, right? So that's pretty good. I like that it keeps track of the voltage range in there. Okay, and we've got our 5 volts. This is showing us the 24-pin. So our 24-pin connector is good. All the 5 volts are good, the 12 volts are good, the 3.3s are good, and it automatically timed out. So I got to tap the button on the side. I tap the button on the side, it cycles through. But yeah, our minus 12 is good. Everything's good. Now I'm checking the PCI. So my PCI connector, 12 voltage, they're all good. And my CPU, they're all good. And there's my Molex. They just call it MOX for short. It's good. And my SATA is good. If this were bad, it would start flashing. The screen would turn red. And I'd know that I have a problem. Like, for example, the SATA, right? It knows to be checking SATA. Let me unplug the SATA. And look, it's going to say, no, I'm failing. All of it's failing. And that's what it looks like when it fails. So, guys, that's pretty much it. That's how we test a power supply using either the multimeter or our fancy power supply tester or our really fancy power supply tester. So remember, the causes for a bad power supply or indicators can be The PC won't turn on, shuts off periodically or randomly, especially when we're trying to do things that can indicate that it's underpowered. We got to remember safety. PSUs, these are field replaceable units. We don't open them up. The components inside, we just throw the whole thing away, because if you open it, there's capacitors in there. You got a risk of shock. We don't want to wear any long jewelry or anything around these fans that might get caught inside of the fans. And, that's it. Our multimeter, most are not auto ranging, right? A lot of them, they have, you've got to select the voltage range, okay? And we go for the one that's just high enough to test what we're testing, right? So let's see, I think that's it. So, and then we went over each of the connectors, but we went over that multiple times. So I'm sure you guys got it right now, by now, right? All right, so good luck. Hope you